Okay, hey everybody. Welcome to Monday and welcome to the homework assignment out of the book. We're doing 2.3.4. It's actually the last assignment before we do the review problems called closure, right? So 2.3.4, how can we rewrite products? That's the theme. Very cool thing here. It talks about distributive property. Okay, and that used to be a tough thing for us teachers to teach. But the one thing I really like about this book is it really emphasizes that generic rectangle, right? And when you use a generic rectangle, it makes the distributive property much easier to understand and to use and to teach. So looking forward to that. Anyway, let's get those most important or the easiest 3 points, right? First off, you are writing your first and last name. And we're going to be Alex Trebek today in honor of a good man who passed away over the weekend. He used to host a show called Jeopardy, which was a show, it was just, you had to know a lot about a lot of things to do well on the show, and I really liked it. It really celebrated knowledge and it was a good game show. It's a game, but it was a game show based on knowing things, which is kind of cool for a teacher, right? Or anybody who really values that kind of thing. So we are doing lesson, let's call it 2.3.4 in chapter 2, and the problems we're doing is 2-86, and we're going to go all the way through 2-90. But like I say, if you want, just so there's no confusion, you can actually list each one. It doesn't take that long. Whoops. And 2-90. Okay. All right. 2-86. And again, make sure you're putting that right parentheses on these things, or circling it, or somehow separating the problem number from numbers in the problem, right? So you don't get confused. Even saying that's a little confusing. So what do we have here? We have list the generic rectangle at the right, or look at it, and then what two numbers are being multiplied using this rectangle? How can you tell? And write the product of the sum of the areas and fill in the answer, and then use the distributive property to write. That's going to be the really hard part here because we haven't practiced yet, but I'm going to show you that. This box should help, okay? I always think a distributive property is like you're dealing cards in like the game Uno or something, or Crazy Eights. You want to make sure everybody gets the same number of cards, and the dealer's outside the parentheses, and the people inside the parentheses are the terms inside. So this is kind of a weird generic rectangle. We got 500 here and 20 there. We have 150 here and 6 here. So this is a tough sort of puzzle type problem. The first thing we need to do is we need to figure out what goes in these 4 spots, right? Okay, now there's a 0 and a 0. There's 2 zeros. So I think that these are going to be in the tens place, right? And these will be in the ones place. And so I'm thinking, what numbers multiplied together equals 6? Well, 3 and 2 and 6 and 1. And when I go over here, I think what goes here? Well, a 1 could go there, but that would make that 150. I can't see 150. So I'm thinking there's going to be a 3 and a 2, right? And since 3 doesn't go into 20, I don't think that's the 3. I think that's going to be the 2, which would make this a 10, which would make this a 50, which would make this a 3, which fits there, right? All right, so you have what two numbers? 52 times 13, okay? Okay, so that was pretty much A. I kind of did that for you. Hopefully you paused it and tried it on your own first. Now you want to say, it says write the product as a sum of the areas to find your answer. So we could do this, but we could also do 500 plus 150 plus 20 plus 6. Okay, you're going to do that. and then use the distributive property, okay? So the distributive property, write an equation. When you look up here, it's written like up here, okay? So we have 2 digits and 2 digits, so it's a little trickier. Um, you know, 13 times 52 is the same as 13 times 50 plus 2, right? And this is the same as 10 times 50 plus 2 plus 3 times 50 plus 2. Okay, real big problem, but now it kind of makes sense, right? Because we have 10 times 50 plus 10 plus 2, 10 times 2, and 3 times 50 plus 3 times 2. So let's get the entire problem. 10 times 50 plus 10 times 2 plus 3 times 50 plus 3 times 2. Okay, and that's kind of what we do whenever we do the generic rectangle. But writing it out like this is it's a difficult next step. Okay, but we're going to practice this. We're going to get good at this. It's difficult because it's new. Everything's sort of hard at first, and that's why you say I'm not good at this, and you add that 3-letter word. What is it? Yet. Very good. Okay, section 2.1, you learned how to create dot plots, bar graphs, histograms, and stimuli plots. Which of these representations would best display this data? See 10, 8, 12, 10, 10, 9, 10, 11. Okay, so all of these numbers look like they're between what? What's the range here? Smallest number looks like it's an 8. The biggest number looks like it's a... So I'm going with that dot plot on this, right? A dot plot is very similar to a bar graph if you want to turn it into a bar graph as well. But let's make a dot plot on that. And I'm just going to get you started a tiny bit here, right? I'm just going to come down here and I'm going to write 8, 9, 10, 11, and 12. Okay? You have fun with that, and we'll check it with the next video. But I think you can do that. Okay, you're basically going through these numbers and you're putting a little X or a dot above those numbers anytime you see it. Okay, this next problem, we haven't seen these in a while, but we're talking about patterns, right? Patterns, and can you figure out what's going on here? I'm going to go ahead. Remember, paper's cheap, all right? I could write on the back of this, but since I'm writing in pen, I don't want it to show through. We basically have 4 number lines here, and it says use the number lines, and they're missing numbers, all right? And so sketch them out and try to find out what the missing numbers are. So here, and remember, technically a line goes forever in both directions. All right, and I got 3, then I got a 12, then an empty spot, then I got a 20, and then I got a 24. Okay, now these next to each other help me, right? That's usually a good place to start. How much are those apart? Right, that's usually a good place to start. This next one starts with a 10, and then it has 1, 2, 3, 4, and then there's a 60. Okay, so again, what's in between those and how many spaces, right? And see if you can figure that out. I almost don't want to help you on some of these, but I'll tell you what, after we're writing this, before I go, hopefully I will remember to come back and give you a couple of hints on these. Okay, and D, and again, I'm giving myself all sorts of room. It starts with 15, This is 35. Okay. And yeah, these are puzzle type problems, and I don't like to solve the puzzle for you. I like you to have your fun. But I'll tell you what, I'll give you a chance to say spoiler alert, and I will help you. And then you can pause it beforehand if you don't want help, and check on it before, and you can sort of end the video a tiny bit early, and then just check the answers tomorrow. Or you can get the answer or get a hint today. Okay, whoops, this is supposed to be 3/8 equals how many 32s? And again, think magic one here. 8 times what is 32? Because whatever I multiplied that by, I got to do the same thing on the top, right? That ends up being, right, if I want to be something be equal or equivalent, then the only number I can multiply it by where it won't change its value, it might change its looks, but it's not changing its value, is a 1. So what did I multiply the 8 by to get that, and do the same thing? If that's here, the same number has to go on top for this to be 1. Okay, so that's your hint on that one. And I want you to do the same idea when you go the other way, 80 hundredths. Now you're going to divide this by something to get 10 and divide, right, by the same thing. And last one, 1/2 equals how many 250s? Okay, you're going to figure that out. Now, these last ones, we're just practicing things we've learned, right? We're doing operations, and we're just doing it with decimals, right? And remember, when you add, subtract, or compare decimals, you want to line up the decimal and stack them. So I'm putting for the 18 and 3/10, I put the decimal down first, then I put the 8 and the 1, then I put the 3. For 11, where's the decimal? Can you see it? Can I focus in on that? Yeah. If you can't see it, where does it belong? To the right side. Right? So once you do that, this becomes easy. Sometimes we say, okay, you know what? That looks weird because they don't come out to the same spot. Add zeros after the decimal. Make it look so it's not as confusing. Okay. On B, 290B, we're doing 9 2/10 when we're subtracting, and remember, I'm going to write the decimal first. And this is where it becomes crucial that you add those zeros, right? If not, you're really tempted to just bring the 5 and the 7 down. Well, you got to go borrow, huh? Okay. All right. How about this one? 275 plus 27.5. Ooh, line up that decimal. It's so, especially with those numbers being the same, 275, you want to put them one on top of another, don't you? All right, put it like that. And then once you line it up right, it's hard to get these wrong, right? You know how to multiply, you know how to add, subtract. So 90, where's the decimal? All right, so I'm putting the decimal here. And then again, what helps me make sure I don't get these wrong? Yeah, fill in zeros. Okay? All right, I think you guys can do this. I think I've helped you enough on this. Answers will be coming tomorrow. Spoiler alert, if you want some hints on these, I'm going to give you some hints. If you're good without hints, end the video now and go get your homework done. Okay? All right, hints for this. 24 minus 20 is 4, so I'm thinking this space is going to be a 4. And when I go 4 here, I get 20 minus 4 is what? And I see that 12 plus 4 is. So it looks like each of these are changing by 4, right? Now here, both these end in 0. What numbers do I know, right? Go into 10 and 60. Well, I'm thinking this might be 10s, right? 20, 40, 60, or 20, 30, 40, 50. Oh, all right. Enough of that. This is a tough one, all right, because I have 1, 2, 3, 4 spaces. And here's the one you really want, all right? 41 minus 13 equals 28. 4 spaces divided by 4. That's your hint. That's your hint, okay? And then this is almost, you're playing hide and seek, counting by 5s, right? 5, 10, 15, 20, 25, 30. That's your hint on that one. I don't think you need much on that one. All right, go. Good luck. Get this done, and we will see you tomorrow to check your answers, okay?